Dear colleagues, I wish you a good day and let me present you a report on our ATTRACT project titled Development of Radiation-Hard and Cost-Effective Inorganic Scintillators for Colorimetric Detectors based on binary glass composition doped with cerium. Acronym is SCINTIGLASS. The aim of our project is development of industrial technology for cerium-doped glasses to compete with the conventional scintillators with high light yield, fast response, and high radiation tolerances for a cost-effective mass production capability. Since October of the last year, our SCINTIGLASS consortium succeeded in production and testing of detector units prototypes made of glass and lead plates with single-sided and double-sided readout using glue wavelength shifter bars. Some photos of the prototypes are reported on the first slide here. A photo of custom-made power circuit board with silicon photomultipliers and preamplifier are also presented here. The next bullet point is we obtained promising test results with americium beryllium source, demonstrating a good potential of the scintillation glass for detecting neutrons in wide energy range, as it is presented on the bottom left figure of the slide here. And the next point, two glass-making companies from Germany and Czech Republic expressed their interest to participate in further R&D of this glass scintillator on an industrial scale. Moreover, we are going to invite a few more research groups from other research laboratories who can provide a deeper expertise of the material properties and technology optimization to join to the project. And updated prospective points for ATTRACT Phase 2 are presented on the second slide, as you can see here. And thank you very much for your attention, and I wish you a good day.
Hi, my name is Istvan Grexa. We at the Biomag Research Group are developing the SpheroidPicker device that can automatically handle cell-derived spheroids. 3D cell cultures are predicted to be the next generation of drug discovery models, since they can better model disease physiology than the so-called flat models that are two-dimensional. Our team has a working pipeline for personalized medicine in 2D, and we are in the process of extending this protocol to 3D. Since the last report, we have integrated the SpheroidPicker into a pediatric brain tumor project, also supported by the European Union, where we provide personalized medicine treatment. In this work, the SpheroidPicker automates critical processes that are time-consuming and require human assistance. In drug testing, the spheroids should be as similar to each other as possible to get accurate results. Our device selects and then manipulates the spheroid based on user-defined criteria, for example size and circularity. Also, we have improved our detection and segmentation method and made it more precise. We have extended our annotated database, which now contains spheroids of 4 different cell lines. The reliability of our object detection is increased to about 99%. We showed that our modified Mascar-CNN AI model outperforms classical methods and other deep learning-based detection and segmentation algorithms. However, if we compare UNet to Mascar-CNN, we find that there is a trade-off between finding the objects more precisely and having better segmentation. Since we are using the results for robotic system coordination, we choose to have better object detection, which is provided by the Mascar-CNN. We have been using this system for almost a year now, and we are about to achieve technology readiness level 7. We will continue the work by supporting even more types of plates, making the device cheaper by using 3D printed parts and professional manufacturing. This enables us to make it widely available for other laboratories, but we have already shipped another prototype to our collaborators in Helsinki. We believe this will make working with spheroids much easier and automate processes in drug discovery and cancer research. Thank you for your attention.
Welcome everybody, this is Mario Ceresa and I'm the coordinator of the MIIFI project from ATTRACT Phase 1. I'm here to present some of the updates since October 2020. At first, let me briefly remember the objective of the project. We wanted to improve fetal surgery by integrating MRI, ultrasound, fetoscopic, and other multimodalities imaging all together in a single surgical planner, to add to it a placenta navigation system, and finally show everything on a mixed reality headset directly in the eyes of the surgeon. We are in advanced state with this project that finished recently. We have a very beautiful anatomical representation that we are able to model in 3D. We are able to simulate the surgery in virtual reality. And since October, we advanced on 3 fronts. First on the dataset, where we, last time we said that we had around 88 cases, now it's more than 107, and they include all images and clinical data, MRI, ultrasound, fetoscopy, timings for the surgeries, a lot of things, which makes the dataset very interesting. Second, on the mixed reality part, we entered in an agreement with Epic Games to develop a fetal training app with Magic Leap headset. We think it's a very interesting part because it shows that our project has a very concrete technical applications. Then on the consortium, we started assembling a joint consortium with Antonio Ferretti from Brains, Alvaro Bertelsen from Sugar, and Jap Heukelom from Visionaire around mixed reality solution for different interventions in the operative room. If our project was to be selected for Attract Phase 2, first we would like to scale up. Similarly to what we said in the last presentation, we have a beautiful online architecture. You can click on the link to show the details. We also released open source a JavaScript client that helps the clinicians connect to our server and upload the image for processing. Furthermore, we conducted a market research and found that the software market value for healthcare and augmented reality is around 5 billion, total addressable market from Goldman Sachs. In addition to that, on top of that, the market for education on augmented reality is around another 700 million. So, very big numbers. In order for this to happen, we would like to have a consortium, as we said before. We talked with the University of Chieti, a private Spanish company called GEMTEQ, a startup from Italy on medical image analysis called SERV, and also a developer of hardware headset, Visionaire, which has a public and private institution. We also would like to contact the manufacturers of HoloLens 2, Microsoft, to see if we can receive help in the integration. First, we would like to comment that apart from the big project from Attract Phase 2, many people asked us to go towards training for clinicians. As we said before, the market is big, targeting the education of future clinicians. We also develop the market further. So we think that our first project could actually be a surgical trainer for minimally invasive procedures in AR. And the big project we would like to present for Phase 2 is called the Hero Surgeon, and it will integrate all important information from the UR, being it monitors, surgical planning and multimodality, sensors on the patient and the surgeon. We would like to do this in order to solve the hand-eye coordination problem, where the surgeon has to continuously switch between the monitors and the patient, and does imaging in itself the different perspectives. Also, we would like to solve the cognitive load problem, which means that the surgeon has to continuously look for the information which is more relevant around themselves, and instead he would like to have all this information delivered to him through the headset. The project will be centered among 3 main surgeries. The first one will be fetal, which in case the project, the consortium, the project is given to the consortium, will be led by people from MIIFI. It will work on super resolution, biased segmentation, real-time imaging. Brain surgery, which would be in case led by brains people, without tumor mapping, electrode insertion, trajectory planning, and brain shift. And spine surgery, which will be eventually led by GEMTEQ, with visualization of trajectories and visual and sonic clues for safe margin insertion. As for the complementary funding, we've been very active on this. As we said, we just received an Epic Mega Grant from Epic Games to develop a prototype for fetal surgery training using a real engine on augmented reality. And we also would like to apply to European and national calls, like this one from Attract Phase 2, to develop the MVP for interoperative part, because it's more complex and requires the effort of a bigger consortium. Thank you very much for your attention. For any questions, do not hesitate to contact me.
Random power was born to generate, distribute and exploit unpredictability in the form of a virtually endless stream of random bits. Designing, producing and qualifying a credit card-sized random bit streamer was the main goal of the Attract Phase 1 project, and the mission was successfully accomplished. Since October 20th, a lot happened. First, we ran an international hackathon, unfortunately remotely. Then we entered the Startup Lombardia competition and we got the first prize in ICT, gaining us €25 and the access to the next level nationwide. There, we did well. We entered the set of the top 4 most promising startups to be, and we won 2 prizes by Progress TT Fund and LeftTT, 2 venture capitals that are ready to invest in the project, and we are currently in the negotiation phase. These results, as you can guess, boosted the enthusiasm of the team, which is by now more committed than ever. In terms of evolving the project in view of the Attract Phase 2 and beyond, we start out by the following analysis. Technology-wise, we know actually where we want to go, and we want to grow micro, scaling up what we currently have to multiple generators for infrastructural and server-based application. We want to go micro, integrating all of the functionalities into a system on chip. And we want to go secure, embedding a real-time sanity check of the bit stream on board. Obviously, it would be foolish to claim that we can do everything on our own, and we intend to enlarge the consortium with teams with expertise in designing micro-integrated systems, with mathematicians and cryptographers, and notably with end users, because the hardware has to be qualified by developing services and applications. It is actually worth saying that contacts have already been successfully established with 3 other teams involved in other Attract Phase 1 project, and also with a set of relevant companies in the field that have declared their interest. In terms of applications, contributing to secure our digital life is our main goal, and we can mention 2 exemplary illustrations. First, seeding HSM, hardware security modules, namely the appliances for generating, storing, distributing cryptographic keys. Then, developing practical full homomorphic encryption, certainly a visionary approach to privacy, which is based on the capability to perform analytics on encrypted data. Now, in terms of investment, our main funding strategy is based on public research grants dedicated to mid-term, visionary and high-risk developments, which is complemented by resources which are drained from investors to address short-term innovation actions and probing the market. As you can see by the first slide, we actually entered already the game. We made it successfully, and we intend to continue.
The aim of PRIMELOC is to provide the first proof of concept of the personal radar idea, which will give future personal devices like smartphones and wearables the ability to infer maps of indoor environments, as well as of self-localizing with high accuracy, without the deployment of dedicated infrastructures. This has been achieved by designing massive antenna array technologies at millimeter wave, as well as advanced signal processing algorithms implementing radio-based simultaneous localization mapping. Our project is coordinated by the University of Bologna, Italy, and the partner is COAL-80, France. The last activities has been devoted to the migration from the millimeter wave technology at 28 GHz to the terahertz technology at 300 GHz. In particular, a first prototype of an antenna array at terahertz with a fixed beam has been implemented and used to carry out a measurement campaign to characterize the Beschetted response of real environments in the terrace band. Starting from measured data, radio SLAM algorithms has been tested. Preliminary results indicate that a better localization performance can be obtained with respect to the millimeter wave technology. The next step to scale the technology up is to embed it into mobile devices. Recently, it has been foreseen that 6G wireless networks will be based on the combination of several functionalities such as communication, localization, and imaging, thanks to the adoption of the Tera-Earth and massive antenna array technologies. PRIMELOC technology is expected to provide important contributions along this line. In fact, working the Tera-Earth band will bring several advantages such as a smaller size of antennas so that much more antennas elements can be packed in the smartphone, allowing for pencil-like beamforming and more precise mapping localization. Moreover, in the Tera-Earth band, better exploitation of diffuse scattering from the environment than at millimeter waves is possible, with consequent improved mapping and SLAM performance. Towards this direction, a prototype of mesh antenna array at Tera-Earth with a fixed beam has been recently implemented as remarked before. In step 2 of the project, we plan to realize the electronic beam steering functionality. In perspective, the consortium can be extended by involving academia from the field of wireless communications and R&D centers with expertise in facilities in antenna design, radio sounding, IC design, and clean rooms. The involvement of at least one big manufacturer in the fields of wireless communication, radar, and verticals is also fundamental in perspective. To this purpose, patent filing, the participation of industrial fora, and the organization of scientific events represent the main occasions to create a network of collaboration. The personal radar concept is expected to pave the path for accurate representations of indoor spaces, automatically generated and continuously updated by users. Infrastructure-less localization can be used, for instance, to track pandemic situations similar to COVID-19, where it could be possible to trace back all the indoor locations visited by an infected person in order to check who visited the same places in the previous weeks. Applications can be found also in the field of safety, for instance, to assist firemen in unknown and dangerous environments using self-localizing unmanned autonomous vehicles.
Hello, my name is Johannes Leidner and I'm a scientist at CERN working on the GEMTEQ detector. Today I would like to present an update on our ideas for a Phase 2 ATTRACT project with the working title Advanced Detectors for Imaging and Dosimetry in Hadron Therapy. The ideas are based on the two ATTRACT Phase 1 projects that our group at CERN conducted, namely the project on a large area GEMTEQ detector with optical readout for hadron therapy, the LaGEMPix project, and the project on a GEMTEQ detector for microdosimetry with tissue equivalent gas, the GEMTEQ project. The Phase 2 project would aim at developing advanced detectors for hadron therapy, as they are essential for improving dosimetry and quality assurance procedures. New technologies and detector concepts tested with prototype detectors in the ATTRACT Phase 1 lay the foundation for enhancing the spatial resolution of detectors for measurements in hadron therapy and for gathering additional knowledge such as microdosimetric information. Since the official end of the Phase 1 projects, we have continued our work on the GEMTEQ and LaGEMPix projects. We have designed a vacuum vessel for the GEMTEQ detector in order to achieve a sealed and low-pressure detector. This will increase the equivalent spatial resolution in the GEMTEQ and allow for measurements in places without gas lines. We will start testing the device in spring 2021. The LaGEMPix prototype detector obtained during the Phase 1 is currently being upgraded by reducing the gap between the amplification stage and the readout system to accomplish finer spatial resolution. At the same time, a new LaGEMPix detector is being produced. This detector is based on a TFT-only readout, therefore detecting electrons instead of photons, which will allow for an even better spatial resolution. It will be tested in spring 2021. Furthermore, we have performed first test measurements of a novel dosimetry system for neutrons. The measurements were performed with reactor neutrons to gain knowledge and to prepare for a possible application in boron neutron capture therapy. We have also established contact with several potential partners for a possible Phase 2 application. Regarding an ATRAC Phase 2 project, our technology has proven to be scalable as it is based on two already existing technologies that have been independently tested in various applications. Nevertheless, a lot of R&D work is needed before they can be implemented in clinical practice. We would need to extend our actual consortium and partner with the Hadron Therapy Center as the end user of the detectors, research centers for tasks such as detector characterization, detector development companies having interest and expertise in the medical product market, and companies for the production of the various readout technologies. We have established first contacts with the Italian National Center for Hadron Therapy, CNAO, with other ATRAC Phase 1 projects, and with our current partners for the detector production. Advanced detectors would improve hadron therapy as a modern cancer treatment modality by allowing for optimized quality assurance procedures and more effective sessions for the patients. Recently, the idea of boron neutron capture therapy has seen a reboost. It would require the development of necessary detector equipment, for instance for quality assurance measurements. Thinking of contacting potential investors, we would ask the CERN Knowledge Transfer Group for advice.